liftoff of the mighty Delta IV Heavy rocket with NASA's Parker Solar Probe.
Ever since NASA's Parker Solar Probe launched into space in 2018, it has been circling closer and closer to the sun and taking images along the way. In December 2024, it made its record-breaking closest approach to the sun. That's when it took these historic close-ups of the solar atmosphere, images that are changing the way we understand our star.
With images like these ones, we are actually going to have this full understanding of how the solar atmosphere works, and in particular, to try to predict the solar activity and mitigate its impacts.
The images were taken by the spacecraft's Wide Field Imager for Solar Probe, or WISPR, which observes space in visible light. WISPR doesn't look at the sun directly. Instead, it captures solar material just as it comes off of the sun. When it took these images, the spacecraft was only 3.8 million miles from the sun's surface. If Earth and the sun were 1 foot apart, Parker Solar Probe was about half an inch from the sun. At that distance, the spacecraft was immersed in the solar atmosphere known as the corona. Here, streams of electrically charged particles flow outward from the sun at over 1 million miles per hour, forming the solar wind that fills the entire solar system. These images reveal previously unseen details at the origin of the solar wind.
The amount of clarity and the amount of details that we got from Parker Solar Probe is totally unprecedented. But also we see phenomena that you didn't really see before, and that's where the fun begins.
If you look closely, you can see key features in the images. This is a collision of 3 large outbursts of solar material known as coronal mass ejections, or CMEs.
The most impactful events, multiple events that are one following the others, and understanding that interaction between CMEs will help us also have another view of their potency for space weather.
When the most impactful eruptions reach Earth, they can trigger auroras, but they can also harm satellites, disrupt power grids, and expose astronauts to dangerous radiation. On the far left, there's another key feature. This region marks an important structure known as the heliospheric current sheet. If we zoom out and look at the sun from the side, the current sheet looks like a twirling skirt that extends out from the sun and across the solar system. This invisible current sheet is a boundary separating where the solar wind's magnetic field changes direction from north to south.
It surrounds the whole sun, and it never disappears. That's actually one of the regimes of the solar wind that we have to understand.
The current sheet is important to study because it can affect how impactful eruptions can be at Earth. We've never seen these phenomena in such detail before, and scientists are continuing to study these images to piece together how the sun affects Earth and the rest of the solar system.
Parker Solar Probe is opening our eyes on a new reality about our star, the sun. It is rewriting the textbooks for us.